Hi, my name's Ryan, and you may be asking yourself on this frigid fall afternoon, what is matter? Well, let me tell you something about matter. Matter is a wondrous thing. As the excitements of this video unfold, you'll be learning about the properties of matter, the stages of matter, and the changes that matter undergo. For example, this basketball is matter. Now, matter is anything that is made of mass and takes up space. Now let's get more into it. Woo! Gotta put in that work for the big game. Let's see how Nick's doing studying for the big test tomorrow.
Man, this matter stuff is just so hard. I don't know what to do.
Hey Nick, having some trouble studying for the big test tomorrow?
I just can't seem to wrap my head around this matter stuff. I don't know this.
Hey, well listen, matter's a tough subject to wrap your head around. Luckily for you though, I know some scientists that'll help you out with that. Now, all scientists have a common goal of turning on that light bulb in young students' minds. Now, you recently learned the definition of matter, but did you know there's 4 states of it as well? That's right. First state is the solids. Now, the solids have definite shape and volume, like this, and this, and this, and this, and...
Now, the second state of matter is called a liquid. A liquid is a state of matter that flows. It has a definite volume, but no definite shape. It always fills the shape of its container.
Now, gases are the third state of matter. See, gases are really cool because they have no definite shape or volume, yet they can form to the shape of the container and fill the volume of the container. As seen in this demonstration, carbon dioxide is being produced. Even though you can't see it. Hey, what's wrong?
I'm just upset.
Why are you upset?
We weren't able to give our viewers an example of the fourth state of matter, plasma.
Well, what is plasma?
Plasma is an ionized gas that's found at low pressures and high temperatures. And it's used in lighting and electric materials. And it also reacts to a magnetic field. How cool is that?
That's really cool. Now, matter has 2 kinds of properties, physical properties and chemical properties. Let's talk about physical properties, all right? Physical properties are properties of an object that can be observed using the 5 senses, all right? So I have this block of wood. I'm looking at it, and I can tell with my sight that it is a tannish color. I'm feeling around the edges to feel that it is sharp, and I can tell that it's grainy. Those are examples of using your 5 senses to determine a physical property. Now, there are 2 kinds of physical properties, extensive and intensive. An extensive physical property is a property that is dependent on the amount of substance present. For example, it is obvious that this block of wood is much bigger than this block of wood. Therefore, this block of wood would weigh more. It would have more mass than this block of wood. Now that is an extensive physical property. An intensive physical property is no matter how much of the block of wood that we have, since this is obviously bigger than this piece, they both still have the same density. So that is an intensive physical property.
Now, the second type of property is the chemical property. A chemical property is described as a property that can be observed and measured only through a chemical change. So, an example would be in the previous experiment, both substances reacted together, which means they both have a state of reactiveness. Now, other chemical properties can be described as toxicity, flammability, and oxidation states.
Now, there are 2 kinds of changes that matter undergoes, the physical change and the chemical change. Here's an example of a physical change. Now, a physical change is a change that alters the substance without changing its chemical composition. Now, what's a chemical change?
Well, you see, a chemical change is a process in which one or more substances change into a different substance by changing their chemical compositions.
Cool!
Let's go outside and take a look.
What you are about to witness is highly dangerous and is being performed by highly trained professionals, so don't try this at home.
Now, what you're witnessing right now is a chemical change. It's a chemical change because by lighting the wood on fire, we are therefore changing the chemical structure of the wood. Now, it is not the same as it was before, so it's a chemical change.
Now, it's scientifically proven that every 30 minutes you should take a short study break. This is good because it relieves your brain of all the knowledge that you're processing.
Physical activity is extremely beneficial while you're studying, so you could go outside and just do something like sports.
Yeah! Now that we are finished with our short study break, it's time to learn more about science. Now we're going to learn about physical changes. Now there are 6 kinds of physical changes in the states of matter.
There's changes that release energy and changes that require energy. Let's get more into that.
Now the first example of a change that requires energy is melting. Melting is when a substance changes from a solid to a liquid. Here's an example.
Now the second change that requires energy is vaporization. Vaporization is when a substance changes from a liquid to a gas. Now sadly, we weren't able to obtain a sample of vaporization because, we are just not cool enough to vape, so we're sorry about that.
Now the third example of a change that requires energy is sublimation. Sublimation is when a solid changes straight to a gas. Now, an example of this is dry ice, which is literally solid carbon dioxide.
Now let's get into the changes that release energy. The first change is freezing, which is when a liquid becomes a solid. You better bundle up in here, because it's going to be below 273.15 Kelvin or 32 degrees Fahrenheit or 0 degrees Celsius.
Now the second example of a change that releases energy is condensation. See, condensation is when a gas changes into a liquid. Now an example of this is in the water cycle, when gas changes into a liquid in clouds after it evaporates from the ground.
Now the final change that releases energy is called deposition. Deposition is when a gas changes directly into a solid without becoming a liquid. Now an example of this is dry ice. And dry ice can form into a solid straight from a gas without becoming a liquid.
Now you've learned a lot, but you're not quite the master of your domain yet. The last thing that we're going to be covering is the law of conservation of mass. Now, this is the theory that matter is never created nor destroyed.
Now, the law of conservation of mass was developed by Antoine Lavoisier in the late 18th century. He did this by monitoring the thermal decomposition of mercury.
Now, here's an example. As I light this piece of paper on fire, you will realize that it starts to combust. However, just because ashes are produced does not mean that the matter was destroyed or created. It was simply transitioned from paper to ash. And that is what matter is all about.
We really hope that this video helped confused chemistry students everywhere understand the concept of matter.
Wow, how enlightening! See, bud? Matter isn't so confusing after all.
Wow, thanks, Kyrie.
Hey, don't thank me. Thank the makers of this video.
Hey, by the way, do you think you could teach me how to ball out?
Whoa, hold your horses there, partner. First you gotta study for the big test tomorrow. But I do know a thing or two about balling out.